Hello students, welcome back. I hope you all are doing fine. We have already covered fundamental principle of counting, permutations and combinations. So now it's time to look at theorems related to permutations and combinations. So let's have a look at that. Let us see different theorems that are related to permutations and combinations. So theorem 1. It says that total number of permutations of n distinct things taken all at a time. So if there are n things and I want to choose n things out of them, total number of permutations of n things taken all at a time will be npn. Now this npn is basically n factorial divided by n minus n factorial, which will be equal to n factorial divided by 0 factorial, and this 0 factorial is actually 1. So this again will be equal to n factorial. So npn will be equal to n factorial. So total number of permutation of n distinct things taken all at a time will be given by n factorial. So let's see the proof of this. If there are n things and n places, so suppose these are n things t1, t2, t3 up to tn, and these are n blank places. So if I want to arrange this n things onto this n blank places, then what are the possible number of arrangements? So for the first place there can be n options. Either I can put t1, t2, t3, t4 or tn. So n options for the first place. For the second place, one thing is already occupied, so only n minus 1 options that are left out. For the third place, again similarly n minus 2 options because 2 things are already occupied. For the fourth one, n minus 3 options because 3 things are already occupied. So the total number of arrangements that are possible will be given by n into n minus 1 into n minus 2 up to 3 into 2 into 1, which again will be equal to n factorial. So the total number of permutation of n things, if we are taking all at a time, that will be given by n factorial. Let us see theorem number 2. Theorem number 2 says that the total number of permutations of n distinct things taken r at a time. So n distinct things taken r at a time will be npr is r factorial times, so r factorial into the total number of combinations of n things taken r at a time. So ncr, so it says that npr is equal to r factorial into ncr, and by the formula also we can see that npr is r factorial times ncr. So what we are basically doing is, in permutations, first of all we are selecting r things out of n things. The total number of ways in which I can select r things out of n things is ncr, and then we are arranging these r things by r factorial ways. Once we have selected the r things, we are arranging these r things onto r places by r factorial ways, and this will be given by npr. This is basically npr. So what we are doing is, first we will select and then we will arrange, so we will get the total number of permutations. Let us see this through an example. If I have 5 persons and I want to make them occupy into 3 chairs. If I have 5 persons that can be made to occupy 3 chairs, so there are 5 persons P1, P2, P3, P4, P5, and there are 3 chairs. I want to select 3 persons out of this 5 persons and then I want to arrange them. So either I can take 5C3, I can select 3 persons by 5C3 ways, and then I can arrange that 3 persons by 3 factorial ways, so 5C3 into 3 factorial. Or I can directly use the permutations, that is 5p3. Let us see the theorem number 3. Theorem 3 says that the number of combination of n different things taken r at a time if p particular things are always included. So I had n things out of which I want to select r things, but it is given that p particular things are always included. So if I want to always include p particular things, now I have to select r minus p things out of n minus p things. So the total number of ways of doing this will be n minus p c r minus p. Let us see this through an example. Find the number of ways of selecting 11 players out of 15 players when MS Dhoni and Yuvraj Singh are always included. So I want to select 11 players out of 15 players, but Yuvraj Singh and MS Dhoni are always included. So 2 players are always included. So now how many players are left out? 15 minus 2, and I have to select 11 minus 2 players out of this 15 minus 2 players. So basically I have to select 9 players out of this 13 players which are left out, so that I can form a team. So the total number of ways of doing this will be 13C9. So these are the total number of combinations of n things taken R at a time when p particular things are always included. Now if p particular things are always excluded, then in that case what will happen? I wanted to select R things out of n things and p particular things are always excluded. So total number of choices will be reduced by n minus p. Now out of this n minus p, I have to select only R things. Let us see this through an example. Suppose if I want to select 6 books out of 11 different books and 2 particular books are never selected. Okay, so I wanted to select 6 books out of 11 books, but 2 books can never be selected. So basically I have to select 6 books out of 11 minus 2 books, that is I have to select 9 books. Out of 9 books I have to select only 6 books. So that will be given by 9C6. Here are some important results related to permutations and combinations. NC0 will always be equal to 1. NC0 is basically n factorial divided by 0 factorial, n minus 0 factorial, which is equal to n factorial by 0 factorial is 1 and n minus 0 factorial is n factorial. So this will be always 1. NCN will also be 1. NCN will be basically n factorial divided by n factorial, n minus n factorial, which again will be equal to 1. NCR is equal to n minus NCR. So NCn minus R will be basically n factorial divided by n minus R factorial into the difference of both of this will be n minus R factorial. So n minus R factorial is again n factorial, R factorial, sorry. So this is again equal to NCR. So I can say that NCR is equal to n minus NCn minus R. So here you can see that the summation of this term and this term is equal to n. So by using this property I can say that if NCx is equal to NCy, then either x will be equal to y or the sum of x and y should be equal to n. Either x should be equal to y or the sum of both of them should be equal to n. Also there is one important result, that is NCR plus NCR plus 1 will be equal to n plus 1 CR plus 1. Let us derive this. NCR plus NCR plus 1 is equal to n plus 1 CR plus 1. Now let us take the LHS, that is the left hand side. So that will be equal to n factorial divided by R factorial, n minus R factorial, plus NCR plus 1 is n factorial divided by R plus 1 factorial into n minus R minus 1 factorial. Now this again is equal to n factorial divided by R factorial. N minus R factorial is n minus R into n minus R minus 1 factorial, and here this is equal to n factorial divided by R plus 1 factorial is R plus 1 into R factorial and n minus R minus 1 factorial. Now if I take n factorial divided by R factorial, n minus R minus 1 factorial common, then I will get 1 by n minus R plus 1 by R plus 1. Now this will be equal to n factorial divided by R factorial, n minus R minus 1 factorial into n minus R factorial, R plus 1, n minus R plus 1 as the LCM, and then I will get n plus 1 in the numerator. So n plus 1 into n factorial will be basically n plus 1 factorial, and n minus R minus 1 factorial into n minus R will be n minus R factorial, and R plus 1 into R factorial will be R plus 1 factorial. So this is again equal to n plus 1 C R plus 1, hence proved. So I hope the proof of this is also clear. We will use this result into our further lecture. Let us see different examples on NPR and NCR. Suppose, consider this example, there are 10 points in a plane out of which 4 are collinear and rest are non-collinear. So there are 10 points out of which 4 are collinear and 6 are non-collinear. And you have to find out the total number of lines that are possible and the total number of triangles that are possible. So let's find out. Let me represent point 1 to point 6 on an arc because they are non-collinear, and I will represent point 7, 8, 9, 10 on a straight line AB. So the total number of lines that are possible will be, if I take any 2 points out of this 10 points, I will get 1 line because only 2 points are required to get 1 line. So if I choose any 2 points out of this 10 points, I will get 1 line. So number of ways will be 10C2, but few cases will be repeated. Like if I connect 7 and 8, I will get line AB. Again if I connect 8 and 9, again I will get line AB. So this line AB is repeated. And how many times this line AB is repeated? It will be repeated. If I choose any 2 points out of this 4 points, I will get the same line AB. So I will remove all these cases, that is 4C2. And again I will add plus 1 because there is one line AB that will exist. So plus 1 because I will count it only once. So first of all I will choose any 2 points out of all total 10 points. Then I will remove the cases that are repeated, and then plus 1 because there is one line AB that is possible. So total number of lines will be given by 10C2 minus 4C2 plus 1. Now if I want to count the number of triangles, if I choose any 3 points out of this 10 points, I will get one triangle. So let me choose 3 points out of this 10 points. So 10C3 minus some cases will be repeated. Which cases will be repeated? Suppose if I choose 7, 8 and 9, then I will get a straight line instead of a triangle. If I choose 8, 9 and 10, again I will get a straight line instead of a triangle. So all these cases will not be accepted. So we will have to subtract those cases. Now how many such cases are possible? If I choose any 3 points out of this 4 points, out of 7, 8, 9, 10, if I choose any 3 points, I will get a straight line instead of a triangle. So I will have to remove those cases. So minus 4C3. So total triangles that are possible will be 10C3 minus 4C3. Or you can use the second method, that is we will make separate cases and then we will count it. We will take the non-collinear points separately and we will take collinear points separately. So if I want to count the total number of lines, there can be 3 cases. Either I can take any 1 point out of this 6 non-collinear points and join them with any of 1 point from the 4 collinear points. So I will get 1 line. Or what I can do is case 2, I can choose any 2 points out of this 6 non-collinear points, then also I will get 1 line. I can choose any 2 points out of this 6 non-collinear points, and the third case will be line AB. If I join all the collinear points, I will get 1 line, so that will be line AB. If I want to count the number of triangles in a similar way, what can be the possible cases? Case 1 can be, I can take 2 non-collinear points and 1 collinear. Case 2 can be, I can take 1 non-collinear and 2 collinear, and case 3 can be, I can take 3 non-collinear. Okay, so from the first case I will get 2 non-collinear, 1 collinear, 1 non-collinear, 2 collinear and 3 non-collinear. So the total number of triangles will be the summation of all these cases. If you have any doubts, then you can log into www.askIITians.com and then you can click on the discussion board, which will redirect you to this page where you can see Ask Expert on the right hand side. From here you can select the category of the question and you can post your question here for free, and the experts at Ask IITians will answer your question within 24 to 48 hours. So this was all about theorems related to permutations and combinations. So next in line is formation of groups, where we will study about how different groups are formed, and this topic is very important from IIT-JEE perspective. So stay tuned till the next topic.